Thank you, Mr. Canoni, for that great presentation. And now, please allow me to introduce Dr. Alvanchi, Distinguished Professor at Sharif University, renowned for his expertise in construction management. With a wealth of experience in this field, Dr. Alvanchi has made significant contributions to both academia and industry. Dr. Alvanchi's dedication to excellence and his commitment to advancing the field of construction management make him a respected figure in the academic community. It's an honor to welcome Dr. Alvanchi, whose insights and expertise will undoubtedly enrich our discussions and endeavors. So please join me in welcoming Dr. Alvanchi. And if I may ask Dr. Khalu to be the chairman of this session. So please put your hands together for Dr. Khalu.
Okay, let's welcome the elementary school children who are here with us. And let's put our hands together and cheer them up. And they'll be conducting some music at the closing ceremony. They are sitting all back there. If you just look back, you can see them all there. So they'll be here for the end of ceremony.
Hello and welcome to our presentation. My name is Amin Alvanchi. I'm an associate professor at Sharif University of Technology, Construction Engineering Management Group. Today, myself and my graduate student, Ms. Tiba Gulzar, are going to present you our research entitled The Comparative Risk Assessment of Concrete Structure Construction of Buildings in Iran. In this presentation, I'm going to give you a brief introduction. Diba going to review the literature for you, then going to discuss the methodology, risk identification, risk prioritization, risk mitigation, the standard form contract, and finally, the conclusion. Unfortunately, we face many failures in our structure in buildings. We face failures in natural and non-natural evidence in our country. And if I ask question, who should be responsible for, or who should we put as responsible for this incidents, designers or constructors, I can kind of read your minds that, yes, we as designers, we perfectly design the structure, but these are the constructors that the blame is on them. And as construction engineering and management expert, I should confess that, yes, you almost right, because the construction process is quite complex. We face many managerial issues in construction of buildings. And this is how and why we face many poor implementation during the construction. And this takes us to the importance of research in construction management of structural systems. And when we discuss about the structural systems, we have two main rivals. We have RC structures and we have steel structures, but by far RC structures are more used in our country. 69% of the buildings are constructed by RC structures because they are more economically efficient, less professional team gonna implement the work, and also we have low maintenance costs compared to the steel. So the importance of management related research and improving the managerial aspects of RC construction is here vital. And in terms of the management of construction, we have a main area of management which is risk management. If we want to avoid failures for our RC structures, we should do the proper risk management to avoid the failures. Now, I'm going to ask Diva to explain the related literature to the risk management in the current state of the art and the gap that we came up with.
Thanks, Dr. Alvanchi. Hi, everyone. Oh, does it change? Okay. Hello, everyone. Moving to the literature review, I'm going to talk about the risks that have been studied and focus we are on it. We grouped risks that we found, and after that, we classified them in 4 main categories, which are design and planning, construction practices, operation and additional risks, material quality and testing, which Dr. Alvanchi in further slides will elucidated. But among these 4 main groups, we are going to talk about the major risks that occur more frequently, which you can see in the right side of of the slide. Which the first one is insufficient load calculations. Second one is poor placement and compaction. Curing issues, inadequate design, usage of poor quality materials and testings, corrosion of the reinforcement, lack of supervision and quality control, cracking, and then the last one, natural hazards such as earthquakes. Let's jump to the gap analysis. To shed light on the gap, we are going to identify the risks in concrete structures that are not properly identified, classified, and addressed in Iran. So it's a huge problem for us. In another hand, we have the capacity of the fair and the balanced contracts of concrete structure constructions, which address and mitigate this issue is such a important and have a pivotal role in our nowadays construction society. And the last one, I have to say that to address this gap, we are going to aim that with performing a comprehensive risk assessment of concrete structure construction contracts. It's a bit huge in Iran, and utilize the capacity of concrete structure contracts to mitigate the prospective issues. Thanks.
Okay, thank you. To address this problem, we first identified the risk factors in concrete structure construction. Then we prioritized the most important risk factors, and the mitigation strategies were developed based on for the high priority risk in the form of contract clauses. We wanted to use the capacity of structural structure construction contracts, and we developed the related clauses to that, and finally we developed standard form contracts for these construction projects. First step was the risk identification. For risk identification, we first reviewed the entire process of RC structure construction process. We got familiar with that and went in the detail of the operation. Then from the literature, initial list of risks was identified, and after that, a qualitative field survey based on the brainstorming was performed to identify a long list of risks related to the concrete structure construction in Iran. This diagram shows the procedures we went through, initial list of risks from literature. After that, we categorized the risk and used brainstorming for coming up with 32 risk factors. And for prioritizing the risk and coming up with the high priority or important risk, we distributed a questionnaire between 66 professionals in the industry, asked them to rank the risk in the Iranian market. Our 66 respondents, here you can see the demographic of them. We had 42% of bachelors, 51% of masters, and 6% of PhDs, professional in the industry. And the sample here you can see more than 75%, kind of 75% of them had more than 6 years of experience. Before we go to use the achieved results, we did the statistical test on the results to make sure about the consistency. The Cochran's test showed us the 57 response required for our analysis, which we came up with 66, and the Cohen-Bosch alpha of 0.96 showed excellent consistency. So we could rely on the received results. Here, the top 7 risk factors in the Iran market you can see, and we use these high rank risk factors for our mitigation strategy. We use the Pareto principle, which in Pareto we have 20% of the risks that are responsible for 80% of issues. So we want to kind of address this main 20% of the risk to come up with the majority of failures and issues in the construction of RC structures. So risk mitigation developed for every risk factor. As I said before, we wanted to use the capacity of contracts, so in form of clauses that were developed. The first risk factor was incorrect assessment of soil conditions, which basically gives wrong information to the design team. And to avoid that, the mitigation clauses were recommended. The soil sampling process should accurately follow the National Building Code, and the contractor is responsible for any violation. The soil testing should be done only in certified labs, as mentioned in the aggregate list. So this should be mentioned in the contract, that which labs can be used for sending the samples. The owner is responsible for expenses of the soil sampling and testing process. So this is, again, items that should be indicated, and responsible person for each issue should be identified. The second risk factor was collapse of excavated foundation pit, that we unfortunately face many of them in the country. So to avoid that, these clauses should be again added to the contract. The retaining wall should be constructed right after peak excavation with no delays, in accordance with the structural design. The construction of the buildings, the structural system, should begin right after the excavation and stabilization process is complete, and continues with no delays up to the ground floor. And the owner is responsible for the expenses here, and the contractor is responsible for any delays in pit stabilization and construction of the structure system, if required money or other prerequisites are provided. And finally, the contractor should ensure the construction operation on the owner's expense to address unforeseen geotechnical risks. So these are mitigation strategies for the risk factor of peat. Uh, Two other risk factors, high priority risk factors, are design errors and mistakes and design changes in building control approval. Mitigation clauses should be included in the design contract. In the design contract, the guarantee period of the design contract should cover the entire construction process, and the designer should be kept responsible for any design errors that occur during the construction operation period. This is basically what we already use in the contracts that we've written for the projects in Sharif University of Technology. So this also works fine because when you leave, just when you finish or terminate the contract and connection with the designer, errors come up during the construction periods are difficult to address and they are costly, basically, to refer to the previous designer that is no responsible anymore for the contract. Here, again, in a design contract, the building design should be modeled in BIM-based software, like Revit, to be properly conveyed to the owner and incorporate the owner's view. This is what, again, is issue with the owner. We have non-professional owners that they just see our design but can't comprehend completely the design, and they approve it, but when they start to build the design, they say, no, this is not what I wanted. So building it in a BIM-based design or models can more be tangible for the owner. Design contract BIM models are used to detect also and resolve the possible clashes. This is also important to minimize clashes between different disciplines and elements here. Risk number 5, failure to test material quality. Mitigation clauses that should be embedded in the contracts are here. The materials sampling process should be accurately followed. The National Building Code, and the contractor is responsible for any violation. The materials testing should be done only in certified labs, and the certified labs that are agreed on should be listed in the contract again here. The owner is responsible for the expenses. And risk factor number 6 is low experience workforce. So the issues with low experienced workforce that we face occasionally in our projects, non-aligned columns we see, and poorly cured RCs. So here, to avoid that, only certified workers are allowed to implement the job for the jobs that the certification bodies is available in the country. And a strict quality control and test instructions should be included for each part of the work implementation, and any further work implementation permission should be only subjected to the approval of the quality of the previously performed related parts. So these are important parts that should be included in the contract. And this risk factor number 7 is high fluctuations of material prices. Here, we do not expect that contractor bears the fluctuations and increase in price. So a phrase should be, again, a phrase or clause should be included in the contract that the contract price can be proportionally increased if inflation goes beyond an agreed range of inflation rate. So if we expect 20% or 30% of inflation rate, and that goes beyond that, we should compensate somehow the contractor for the increased cost. So these are the recommended clauses that should be embedded in the contract. So for contract development, we first use the recommended mitigation clauses in the standard for contracts. We also use other references like general condition of the construction contract, 43 one magazine of the management management budget organization of the country. Topics 2, 5, 9, 12 of the national building regulation. Magazine 55 of general technical specifications of construction periods. Iran Concrete Code, second edition, and as well the FIDIC standard form contracts were used to develop the standard form contract suited for the construction of structural systems, RC structural systems in the country. And in conclusion, we basically developed a fair contract format that addresses high priority risk of the concrete structure construction. In this approach basically is an effective approach for avoiding potential risk and removing risk during the construction. This ensures the safety and durability of concrete structure, deters possible substantial financial and human losses, protects parties' rights equally, and minimizes contractual disputes. And by this conclusion, I also conclude this presentation. Thank you for your attention.
Thank you for a nice presentation. Do you have any question about this presentation? Okay, thank you very much.
Thank you.